This assessment asks us to predict the product of the alcohol synthesis shown. Now we'll note that this reaction is the oxymercuration reaction of an alkene, and so it involves two steps. First, addition of water through the mercurinium ion, and then reduction of the carbon mercury with sodium borohydride. We're not going to worry about the mechanism here, but it is always helpful to think about the individual steps. Instead of just jumping and drawing a product, let's think through how this is going to happen. And so in that first step, the reaction is going to start by forming a mercurinium ion. Now, the mercurinium ion can actually form on the top or the bottom. And so in this case, we'll have the mercurinium form on the top. Now, that's kind of an arbitrary decision, but we'll come back and talk about the consequences of if it were to add from the other side. All right, so once we've made that mercurinium ion, we know that water is going to open the mercurinium ion on the side that is most substituted. So at the carbon of the mercurinium ion that is most substituted, but on the opposite face of the molecule. So again, we're not going to show the full mechanism after a proton is removed. This will give us this as our product. Mercury is going to be on the top of the molecule at the secondary carbon. The oxygen, the hydroxyl group, will be at the bottom. That will have pushed this methyl group up, and the isopropyl group has been just coming along for the ride in that position there. We're done with step one. Step two is to simply reduce that carbon-mercury bond with sodium borohydride, replacing it with a hydrogen, and so the product that we end up with will be this one here. Hydroxyl group is still back, this methyl still forward, the isopropyl group is down. Now, we mentioned that stereochemical issue earlier where we said that the mercurinium ion could form either from the front or the back, or could form on the front face of the alkene or the back face. This is the product if that mercurinium had formed in the front. The other product that will be produced, a diastereomer of this, will also be produced if the mercury, for when the mercurinium added on the opposite side. And so this would also be an additional product in the reaction. How do these two differ? Notice the isopropyl group is down in both, but here the hydroxyl group is back. Here the hydroxyl group is forward. So we would expect to get two diastereomers in this reaction.